This is video number 8, density. We all know what density is. Density is the amount of matter packed in a certain space. And we're well aware of the equation of density. The density is equal to the mass divided by the volume. But one of the ways we determine density in physics and chemistry is what we call volume displacement, especially the density of, say, a metal, a piece of metal or something like that. It's difficult to measure the volume of. Maybe it's not a perfect, if it was a sphere, then we can use the volume equation of a sphere. If it was a cube, we could use the volume equation of a cube, length times width times height. But what if it's irregular shape? If it's irregular shape and it doesn't dissolve in water, then we're going to use volume displacement in water. Now we could use other solvents as well if it did dissolve in water. But we're going to talk about volume displacement in water. All right, so let's imagine that we have a piece of metal, in this case silver. So a piece of silver metal, and it weighs 15.62 grams. What we're going to do is take that piece of metal and drop it into some water. So here's a fictional graduate cylinder. We're going to take this piece of metal and drop it down into the graduate cylinder. So here's my piece of metal, and I'm going to drop it down. When I drop it down, obviously, it's going to sit at the bottom because it's going to be more dense than the water is. When I do that, the level of the water is going to rise. And so the water level is going to rise to, we'll just put it right there. Now, we can see the label on our graduate cylinder, 1 milliliter, 2 milliliter, 3 milliliters, 4 milliliters. So let's fill in our experimental data table. This would be our lab sheet that we have here. The initial volume of water is 2 milliliters. And since we know we have markings to the half milliliter, we can do this to 2 decimal places. So we're going to have 2.0 milliliters. Okay? The volume of water once we added the metal is now 3.5 milliliters. So we have 3.5 milliliters. Now, I'm going to calculate using the density equation, D equals M over V, but I only want the volume of the metal. I do not want the volume of the water, the glass, or anything like that. I want just the metal. So the difference here is going to give me that value. That difference is going to be 1.5 milliliters. Then I'm going to take 15.6, divide by 1.5, and that's going to give me the final density.